In this lesson, we shall be looking at megakaryopoiesis or thrombopiesis and lymphopoiesis. So we are looking at lymphopoiesis. So we're looking at lymphopoiesis, and thrombopiesis or megakaryopoiesis. Thrombopiesis, as mentioned earlier on, poiesis in all medical words means production or formation. What are you forming? Lympho. We are forming lymphocytes. What are you forming? Thrombo. We are forming thrombocytes. So lymphopoiesis and thrombopiesis means the production of lymphocytes and thrombocytes respectively. So we shall begin with the hematopoietic stem cell. So we have our hematopoietic stem cell here. Hematopoietic stem cell, which is actually a pluripotent hematopoietic stem cell. This will undergo differentiation. So this will undergo differentiation. We are interested in the lymphoid. So, because we'll be producing the megakaryocytes, we definitely will talk about the myeloid and then the lymphoid. So, this is the myeloid progenitor stem cell. So, we have our myeloid progenitor, which is actually a multipotent stem cell. We have our lymphoid progenitor. So, we have our lymphoid progenitor. So, which is also a multipotent stem cell. And once we are producing lymphocytes, this will undergo differentiation actually to form what is called the lymphoblast. So we'll have our first precursor cell to be the lymphoblast. So we have our lymphoblast. Lymphoblast. Remember, this will start with a very large nucleus, and so you start with a very large nucleus, and as the cell is differentiating, then the nucleus begins to condense, cytoplasmic space increases. And then this will undergo further differentiation to form the So we have the pro-lymphocytes. So we can have either the pro-T lymphocyte, or we have the pro-B lymphocyte, or the pro-natural killer cells. So you can have pro-T lymphocyte. If you are producing T lymphocyte, become pro-T lymphocyte. Or we have a pro-B lymphocyte. Or we have a pro-natural killer cells. And the next terminal cell. So we have them. Then we have the lymphocyte, which is the terminally differentiated. So we have the lymphocyte. So we now have the lymphocyte, whether B lymphocyte, T lymphocyte, and the natural killer cells. If it is the B lymphocyte, all these stages are happening inside the bone marrow. And if it is the B lymphocyte, technically what will happen is that the B lymphocyte will pass through the sinusoids of the bone marrow, then straight into the circulation. However, dealing with the T lymphocyte will have to go to a secondary lymphoid organ. Will have to go to secondary lymphoid organ. We'll go to an organ which is located around the neck. So this is the thymus. So it goes to the thymus for maturation. And once it matures in the thymus, then it enters into the circulation. So once it matures in the thymus, it enters into circulation. So unlike the B lymphocytes and the natural killer cells, they go straight into the circulation. They do not go to any secondary lymphoid organ. But for the T lymphocyte, it will have to migrate to the thymus and undergo further maturation, and then finally the mature T lymphocyte is released into the circulation. So that is basically the stages involved in lymphopoiesis. Now let's quickly look at the megakaryopoiesis. There is a driving force. There is a driving force in this particular blood cell production or platelet production. And the driving force is the hormone called thrombopoietin. So thrombopoietin actually, so we still the same driving force. What will make the lymphoid progenitor cells to go is, lymphocytes are actually agranulocytes, and so we need an agranulocyte stem cell stimulatory factor that will bind to the lymphoid progenitor cells, and it will cause the lymphoid progenitor cell to differentiate into the various types of lymphocytes. And certainly we need interleukin 3, interleukin 5. They will all make the progenitor lymphoid stem cell to move in the direction of the lymphocytes. Then we have the thrombopoietin. We are dealing with thrombopiesis. So thrombopoietin actually is a hormone. It is produced by the liver principally. Thrombopoietin comes from the liver. And so what thrombopoietin does is that, just like erythropoietin, it binds to the myeloid progenitor stem cell. And once it binds to the myeloid progenitor cell, it directs the affairs of the myeloid progenitor cell to begin to commit to the lineage. So it begins to commit to the lineage of thrombocyte production, so myeloid progenitor cells. So we have here the colony forming unit megakaryocytes. Then from the colony forming unit megakaryocytes, so from the colony forming unit megakaryocytes, the next stage is called the megakaryoblast. So we have a megakaryoblast. So we have megakaryoblast. Megakaryoblast, a very large cell. Mega means something large, very large. And from the megakaryocyte, from the megakaryoblast, the next stage will be the pro-megakaryocyte. So we have the pro-megakaryocyte, the pro-megakaryocyte. So we have the pro-megakaryocyte, and then that means that the next stage will be called the megakaryocyte. So we'll have the next stage here will be the megakaryocyte stage. So we'll have the megakaryocytes. So we have the megakaryocytes. And so all these is driven by the thrombopoietin. So colony forming unit, thrombopoietin binds to the myeloid progenitor cells. It differentiates into the colony forming unit megakaryocytes. Then further differentiation gives rise to the megakaryoblast. And this megakaryoblast will undergo further differentiation and proliferation to form the pro. So the pro-megakaryocyte. And once we are in the pro, it means before the megakaryocyte. Then the next stage is going to be megakaryocyte. And once we are in the megakaryocyte stage, that is the last stage within the bone marrow. And as this megakaryocyte is about to exit the sinusoids of the bone marrow, the capillaries within the bone marrow, what happens is that because of their large size, in an attempt to come out, the capillaries or the vessels are too small, tiny, that a very large cell like this cannot pass through it. And in coming out, they break or they fragment. And the fragmented megakaryocytes the fragmented megakaryocytes. So they fragment into pieces or fragments of cells, and that is what we call the platelets. So the platelets are actually fragmented megakaryocytes. So basically these are the steps or the process involved in thrombopiesis and lymphopoiesis. Now that we have looked at the various types of hematopoiesis and the various stimulatory chemical substances or cytokines, let's now quickly look at the terms that are given to elevated and decreased levels of these cells in the peripheral blood. So we want to look at the terminologies for the increased levels and the decreased levels of these cells in circulation. And so we need to establish the cells in circulation. So we have the erythrocytes. So we have erythrocytes. Then we have the thrombocytes. The thrombocytes. And the third one are the leukocytes. The leukocytes, which are called the white blood cells, are actually divided into two on the basis of the presence or absence of granules. So we have white blood cells that have granules in their cytoplasm, and all those white blood cells with granules in their cytoplasm, they have granule. And so when these white blood cells were observed using the rice stain or the Leishman stain, the scientists saw that the white blood cells, some category of them had some noticeable granules, and he called those white blood cells with granules in their cytoplasm as granulocytes. Then another category of white blood cells, he actually did not find noticeable granules. That is not to say that they do not have granules, but they did not see the granules when using the rice stain in the light microscopy. And those white blood cells without granules, he described them without means A means absence. He called them agranulocytes. And so basically these are the cells that we see in circulation, and the granulocytes actually are, so let's look at the granulocytes. So the granulocytes typically are the neutrophil. They have granules in their cytoplasm. Then we have the eosinophil. Then we have the basophil. So these are the types of the granulocytes. Now let's quickly look at the cells that makes up or constitutes the cells that constitute the agranulocytes. So the agranulocytes principally are the lymphocytes. So the lymphocytes and the monocytes. So these are the different types of cells we will find in the circulation. Now we want to quickly look at the terminology that is used to describe the increased levels of these cells in circulation and the decreased levels of the cells in circulation. Now in general, all cells, so all the cells, so in general, the increased levels of the cells in the peripheral blood smear, the increased level of the cells in the peripheral blood or in circulation. So in general, the increased level of cells in the peripheral blood, the terminology ends with the surface, ends with either the surface cytosis philia. So, the increased levels of the cells in circulation either ends with the suffix cytosis or philia. This is to know which of these cells will go with cytosis or philia. We can easily detect that by looking at the ending part of these cells, which of them rhymes with cytosis. So cyte means cell, osis means condition of increase, philia also means increase. So cytosis and philia both typically refers to the increased number of cells. So if we want to know the increased levels of cells that will end with the suffix cytosis, it's just a matter of looking at these cells, which of them does the suffix end with cytosis. So you could hear the name erythrocytes, you could see it ending with cyte, so it rhymes with the cytosis here. Thrombocyte, it rhymes with the cytosis. Leukocyte, it rhymes with the cytosis. Granulocyte, it rhymes with the cytosis. Agranulocyte, it rhymes with the cytosis. Monocyte rhymes with cytosis. Lymphocyte rhymes with the cytosis. Basophil, eosinophil, neutrophil rhymes with what? The philia. So technically, all the cells ending with the suffix cyte will pick up the suffix cytosis as the term for its increased level. And so based on that, then we will have the increased levels of erythrocytes will be called erythro. So erythro, it is ending with cyte, so we pick up the cytosis, so we get erythrocytosis. Then the increased levels of thrombocytes will be called thrombocytosis. So we have thrombocytosis. All cells ending with the suffix cyte will end with cytosis as the increased level. Then leukocytes will be called leukocytosis. So we have leukocytosis. Granulocyte will be called granulocytosis. Agranulocyte will be called agranulocytosis. So we have granulocytosis, agranulocytosis, which means the increased levels of agranulocytes. Then we have granulocytosis, which means the increased levels of granulocytes. In this case, we are referring to neutrophil, eosinophil, basophil. Then we have lymphocyte, and the increased levels of lymphocyte will be called lymphocytosis. Lymphocytosis. And monocytes will be called monocytosis. So these are the terminologies for the increased levels of the cells ending with the suffix cyte in the peripheral smear. Take for instance the cell called reticulocyte. Reticulocyte is an immature red cell, quite larger than the matured one. Reticulocyte, the suffix is cyte, and therefore increased levels of reticulocyte will be called reticulocytosis. In a condition whereby we have smaller than normal red blood cells in circulation, smaller than normal red blood cells, a red blood cell that is smaller is called micro, and because it's a cell is called microcyte. And therefore, if you want to create the terminology for the increased levels of smaller than normal red blood cells or cells in circulation, will be called micro. Its ending with cyte becomes microcytosis. So increased levels of microcytes in circulation is called microcytosis. Similarly, if the cells are larger than normal, they are called microcyte, and increased levels of microcytes in circulation typically is called macrocytosis. So this is how we understand the terminology when it comes to the increased level. But when it comes to the neutrophil, it is ending with the suffix phil. Eosinophil ends with the suffix phil. Basophil ends with the suffix phil. Therefore, the increased levels of neutrophil will be called neutrophilia, because the suffix is philia. So philia rhymes with fill. The increased levels of eosinophil is called eosinophilia. And the increased levels of basophil is called basophilia. So basically, these are the terminologies associated with the increased levels of these cells. Now let's quickly look at the terminology meant for the decreased levels of these cells. So terminology for increased level, terminology for increased levels, for increased level of all the blood cells, of all the blood cells, of all the blood cells, of all the blood cells in circulation, either ends with the surface, either ends with the surface, the suffix cytopenia, or the suffix penia. And so penia is a suffix for decreased level. So cytopenia, penia, they all refer to the decreased level of the cells. And so when we are talking about decreased levels of erythrocyte, then that will be called erythro, because it's ending with cyte, to pick the cytopenia. Decreased levels of reticulocyte will be called reticulocytopenia. Reticulocytopenia. Then decreased levels of thrombocytes is ending with cyte, it will pick the cytopenia, thrombocytopenia. And the decreased levels of monocyte will be called monocytopenia. The decreased levels of lymphocyte will be called lymphocytopenia. So just name it. So, and the decreased levels of neutrophil. Neutrophil is called neutro. So the rest of the cells, the cells that do not have sites in it, the decreased level will pick the penia. And typically those cells are the granulocytes. So we have neutropenia, then eosinophil, decreased level, eosinophil. So eosinophil is called eosinopenia. Then basophil will be called basopenia. So typically these are the terminologies that mostly or oftentimes used to refer to the elevated and decreased levels of the cells in the peripheral blood. Thank you.